All right, my friends, we are back from spring break and it is Unit 16. We're going to start in with some simplifying radicals. Hopefully we remember how to do that. However, we're going to go through a few practice things as well. And then we're going to get into some special right triangles, talking about like a 30, 60, 90, or a 45, 45, 90. Those are kind of two main specials. Then we're going to talk about trig ratios, how to find sides, how to find angles, given the sine, cosine, and tangent. We'll also work with the arctangent, arc, cosine, arc, sine, or inverse, sine, cosine, and tangent. So overall, we're going to simplify radical expressions. That's our first one. We're going to use Pythagorean theorem, and it's converse, because we all know a squared plus b squared equals c squared. We're also going to be able to use that to classify triangles, because if there's an inequality there, it will either mean it's going to be an obtuse or an acute triangle, rather than just a nice right triangle at that. Find the missing side of a special right triangles. We're going to be finding missing sides of angles, right triangles using trig ratios, and angles of elevation and depression. So go ahead, put your name, put the block that you're in, my name, in case you don't know how to spell it, E-R-N-E-S-T-E. Depending on which block you're in, you might need to put tat, glass, or flugrat. And I left a blank page here for some scratch paper, some starters and things. Now we're going to start right in. We have special right triangles. That's where we're going to get to, but right away we're going to start with radical expressions. So the big thing that we need to remember about radical expressions is we need to remember our perfect squares. Our perfect squares are things that such as, well, 1 times 1 is 1, so that doesn't really count. 2 times 2 would be 4. 3 times 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. Now beyond that, if you go to the 13, the 14, so that you know the 169 and the 196. However, those are our main ones. The other thing that we need to remember is that if I have an even number on an exponent, like that little side note here, even exponent will be perfect, because we can divide those exponents by 2. All right, so starting out the first one. First of all, hopefully you realize that 9 and 25 are both perfect squares, as well as y to the 4th is a perfect square because it's an even number. So we're going to take the square root of each. So basically we're saying the square root of 9 over the square root of 25. And then we have the square root of y to the 4th. So the square root of 9 is 3, the square root of 25 is 5, and the square root of y to the 4th is y to the 2nd, because we divide it by 2. We don't divide the number by 2, we divide the exponent by 2. Now the next one, let's kind of scooch on over. I've got 100. Hopefully you realize that 100 is a perfect square because it goes right here with the 10. So if I do square root of 100 is 10, and the square root of x squared, remember we're going to divide that by 2, and that would be just an x. So 10x. The next one, they're all even again, so we're going to divide each of those by 2, and we'll be done. So it's going to be x to the 1st, y to the 6th divided by 2 is 3, and z to the 4th divided by 2, so 4 divided by 2 is 2, so z squared. And the last one over here, the square root of 16, well, that's one of mine over here, so we're going to say the square root of 16 is 4, and divide the exponent by 2, and we're going to have n, or n to the 1st. You need to be able to do these without using your calculator. You need to know how to do square roots, whether you write them all down but without using the little button that simplifies it for you. All right, reteaching, we're going to do simplifying radicals whose radicand is not or is a perfect square factor. So we're going to find we're going to separate the radicand into perfect squares and non-perfect square factors. So I'm looking for the largest perfect square that can go into the number. So first of all, this outside number is a half. That is like a coefficient. When I bring anything else out there, I will also multiply by it. So 20. First, I'm going to note that 1/2 is out front. 20, I'm going to break down to, I would say 4 times 5, because I know that right off the top of my head. I know that it's going to be x to the 4 divided by 2 and y to the 4th and a y to the 1st. So once I divide by 2, I can basically take it out of the radical, because the radical and this dividing by 2 cancel each other out there. So now I can say that the square root of 4 is 2, so I can bring that outside. X to the 4 divided by 2 gives me x squared. And y to the 4 divided by 2 gives me y squared. So now to rewrite that, I have half of 2, which is 1, right, because they cancel. And then I have x to the second, y to the second, and the square root of 5y. Number 2, I've got a 2 and a 20. So again, we're working with that 20. 2's on the outside. The square root of, I'm going to say 4 times 5. And then my x to the 8, I'm going to divide by 2. The square root of 4 is 2. And x to the 8th divided by 2 gives me x to the 4th. So it's going to be 4x to the 4th radical 5. We have a couple more down here. Now I'm not going to give you 20 again. We're going to try 27. Now 27, if I think about what it's divisible by, it's not even. So I'm not even going to try 4 or the listings of the even numbers. I'm going to start with my odd. So 27, does 9 go? 4 does not. So 9 goes into 27 evenly. So I'm going to say the square root of 9 times 3 gives me 27. I could write this as the square root of 9 times the square root of 3. If that helps you, please do so. And then we're going to take the square root of 9, which is 3, radical 3, because that radical 3 stays on the inside. I've got 18, so 18, again, it is an even number, but 4 does not go into it. So let's try 9. 9 does by 2. So we're going to say the square root of 9 times the square root of 2. And then we're going to keep breaking these down. I have an odd number, so we're going to say x to the 8th times an x. And we have y to the 6th. So if I keep them all in the radicals, I haven't divided by 2 as of yet. However, I'm going to take this and say the square root of 9 is 3. 2, there is not a square root of it, so I'm going to keep it underneath the radical. The square root of x to the 8th means I can cancel it out by divide by 2, gives me x to the 4th. The x is just to the 1, so it's my extra. And then my y to the 6th, if I go out the square root and I divide by 2, I end up with y to the 3rd. Okay, now if we get to multiplying radicals, we have a couple of different ways we can think about this. We can either, let's work with breaking down the numbers first, because I know that 27 has a perfect square in it, and so does 18. So I like working with smaller numbers rather than getting really large numbers. However, I could say 27 times 18, innies times innies. However, I will get a large number. So if I were to break down the 27 like we did earlier and say, well, 27 is the square root of 9 times the square root of 3. And 18 is the square root of 9 times the square root of 2. At that point, I can say, well, the square root of 9 is 3. And the square root of 9 is 3. So 3 times 3 on the outside now. And left over underneath the radical, I have a 3 times 2, which would be 6. So on the outside, I'm going to have 9, radical 6. 32 kind of works the same way. 32, I'm going to say 4 does go into it, but it would be 4 and an 8. And I know 8 still breaks down by another 4. So let's try 16. So 16 goes into 32 2 times. And then I still have a radical 2. So the square root of 16 is 4. And then this would be the same as 2 times 2, which is also 4. So the square root of 4, but that breaks down to square root of 4 is 2. So now I'm going to have 8 as my answer. The other way I could have on this one, my numbers, when I take 32 times 2, I do get 64. And the square root of 64 is, in fact, 8. So there are a couple different ways you could have done that one. Now I'm going to square a quantity. So when we square a quantity, we're going to say, I actually have 3 radical 7x times 3 radical 7x. So the 3 times the 3 on the outside give me 9. Underneath the radical, I'll end up with 7 times 7, which is 49, x times x, which is x squared. Now, 2 of the same things end up making a perfect underneath. So now the square root of 49 is 7, and the square root of x squared is x. So I'm going to have 63x. Then I have just one monomial underneath here, like one monomial squared. Basically, I can square this guy, and I can square this guy, and I can square this guy. Or another way to think about that would be to say anything on the inside, if I square it, I'm going to get the same thing on the outside. So let's try this next piece. I've got 4 times 4, which is going to be 16, because it does have adding and subtracting in here. So it's a binomial times a binomial. And then 4 times negative radical 11 is going to be negative 4 radical 11. Then I'm going to get plus 4 radical 11. And then I'm going to get a negative radical 11 times 11, which would be 121. Now, the NE's on the side and the 2 interior ones are going to cancel each other out because you can combine like terms. They both are radical 11s. So negative 4 radical 11 and plus 4 radical 11 cancel each other out. So I'm left with 16 minus the square root of 121. Double check yourself. The square root of 121 is in fact 11. So, oops. So then I'm going to have 16 minus 11, which happens to be 5. I do have some practice set aside for you guys on this, so no worries, you'll get practice. Working with some dividing. Okay, so when we're doing division, we're using the same rules. Inside goes with inside, outside goes with outside. I prefer to stack them for the most part. So I would probably take this 12 radical 17 divided by 4 radical 17 and stack them. So, and then I would say the outs go with the out. So 12 divided by 4 is in fact 3. And radical 17 divided by radical 17 is just 1, because anything divided by itself is 1. So they'll cancel each other out. You could go times 1 if you want to, but my answer is going to end up being 3. The next one is set up for you, stacked. Okay, so 4 over 8 reduces to 1 over 2. Now 48 is divisible by 3, so 48 divided by 3 is going to give me, goes into it, so the square root of 16. And now we know what the square root of 16 is. It's 4. So now I have 1/2 square root of 16 is on top. The square root of 16 is 4. So 1 times 4 divided by 2 is going to give me 4 divided by 2, which is going to give me 2. All right, Now, remember when we had a common denominator? That's kind of what we have on number 3. If I have 30x minus 15 all over 5, that really means 30x over 5 minus 15 over 5. I hope you guys remember that. So then we would separate and actually simplify them, and it would be 6x minus 3. So we're going to do the same concept, but we're going to do it with this number 3 here. And I'm going to say I have the square root of 125 over the square root of 5 minus the square root of 10 over the square root of 5. And we're going to simplify each of those separately. So the square root of 125, well, I don't know that for sure, but I know 5 goes into 125 because they both end in a 5. So 5 goes in there, 2, and that would be 10 with 5, 25. So now I have the square root of 25, which I know is 5. Minus, and 5 goes into 10 2 times, so that would be the square root of 2. So 5 minus radical 2. And I can leave it just like that. The next one I have division. Again, I would probably stack them unless you like to do 12 divided by 4. You can either way, but I like to stack them. So I'm going to say 4 radical 5x. 12 divided by 4 gives me 3. 5 goes into 11. Let's see, 55 11 times, and the x's are going to cancel. So my answer on this one is just going to be 3 radical 11. All right, now we're going to talk about a little bit about rationalizing that denominator. So we went through adding, or we went through simplifying, we went through multiplying, and now dividing. Now we're getting into rationalizing that denominator, which is like a new concept for you guys. However, it will be very important when we're working with these special triangles because we cannot leave a radical on the bottom. So a radical on the bottom is like somebody who's out of control, and just keeps, if you don't take care of them, they end up like causing havoc. So we're going to take care of that radical. You're going to simplify the denominator, simplify, and then you're going to multiply by the radical to get it off of the bottom. So what this really means is radical 3 over radical 3 minus 1 over radical 3. We talked about how you split those up because it's a common denominator. Now radical 3 divided by radical 3, hopefully anything divided by itself is 1. But now I have 1 minus 1 over radical 3. So I have to take care of this piece right here. The other one's already rationalized. This is like 1 over 1. That's fine. I'm going to get rid of this radical by multiplying by radical 3. So if I multiply both the top and the bottom by radical 3, on the bottom, I'll end up getting square root of 9 because 3 times 3 is 9. And the square root of 9, is 3. So now I've rationalized the bottom, and my answer on top then I have is going to be 1 minus radical 3 over 3. You can put the 1 there if you want to, 1 radical 3. Another way of writing that same thing, let me try it over on the side. I've got radical 3 minus 1 over radical 3. I could take the entire thing by radical 3. That gives me radical 9, which is just 3. I'd have to distribute this to both items. So that first part's going to give me 3 times 3, which would be radical 9, minus 1 radical 3. And the square root of 9 is 3. So then to reduce that, what I really have is I have 3 minus 1 radical 3 over 3. So I should make that separate for you guys so you can see it maybe. There you go. It's 3 over 3 minus 1 radical 3 over 3. And the 3 divided by 3 gives me a 1. Hence, I end up with that. The next guy, I have radical 8 on the bottom. The 3 is already on the outside, and the 90 is on the outside because it's not underneath a radical sign. So 3 goes into 90. Let's say 3 goes in there 30 times. And then I can say times radical 8 times radical 8, which is nice. Then I get 8 on the outside. But 8 breaks down. I should have probably broken that down first. That's going to be 4 times 2, so I'm going to have 30 radical 8. So 30 over 8, and I have times, I'm going to say radical 8, hopefully you guys know is 4 times 2, which is going to be 2 radical 2 over 8. Oops, over 2 radical 2 over 8. Then I can simplify them. 30 divided by 8, they both are divisible by 2, so it's going to be 15 over 4. Times 8 goes into there, would be 1, be 4. So radical 2 over 4. Ooh, that looks ugly. That is so not right. Erase, erase, erase. Let's try that again. Got a little distracted. Let me stay focused. All right, let's try that again. Let's go ahead and break down this 8. This 8 breaks down to 4 times 2 underneath the radical. The square root of 4 is 2, so I end up with 6. So I get 6 radical 2. Now 90 divided by 6. 6 goes into 90 one time with 33 left over, makes it 30, so 15. So now I've got 15 over radical 2, multiplied by radical 2, multiplied by radical 2. That gives me 2 on the bottom. So I end up with 15 radical 2 over 2. Maybe that's what I started with originally. Nope, yeah, that is much better. All right, next piece. We're going to add and subtract like terms. Okay, we have to do like radical terms. So we're going to combine like terms. So this is a radical 3, a radical 3, and a radical 3. So now they are going to act kind of like variables. I've got 4 of them, take away 7 of them, which would give me negative 3 radical 3, minus 1 radical 3 gives me negative 4 radical 3s. Number 2, I have x's and y's. So here are my x's. This is a negative 1 of them. So 3 x's, 3 radical x's, take away 1 radical x gives me 2 radical x. And then I have negative 8 radical y and negative 5 radical y. The y's are just variables. So negative 8 and negative 5 gives me negative 13 radical y's. And we're done. A little easier than rationalizing, huh? All right. And the last one of this kind, before I'm going to set you off to do some practice, is let's break it down first because I don't know what kind of radical groups I'm really working with. So 8 breaks down to 4 times 2, and the square root of 4 is 2, so I have 6 radical 2 plus 32 breaks down to 16 times 2, which would be 4 radical 2s. And then I have plus radical 6. And 6 is just 2 times 3. It does not have a perfect square in it, so we're going to say plus radical 6. Now my radical 2's can go together. So 6 radical 2 plus 4 radical 2 gives me 10 radical 2's plus a radical 6. And you can leave it just like that. Go ahead and plan on doing some practice at this point.